Hi everyone, and welcome to a very quick introduction to streaming. Or we are going to see today how to work with real-time data. I am Javier Blanco, I'm Senior Data Scientist at Quix.
And I'm Tomas, CTO and co-founder of Quix.
So before we start, as I said, we are going to work with real-time data, and that means we are going to use streaming technology. So can I ask you to raise your hands if you have experience with streaming technologies? Okay, half of the room more or less. And what about Kafka specifically? Same half, more or less. And Quix? Okay, no worries. So, because half of the room doesn't have that much experience with streaming, and this is an intro, let's start from the beginning. Let's start from the scratch. To understand what streaming is, the easiest way to do it is to compare it to the more traditional way to work, which is batch. So let's think in this river metaphor. That river over there is our data flowing. Think in any system in your company that generates data in real time, your clients accessing your app, whatever, that is our river over there. Under a traditional batch approach, we store some piece of that water in a bucket, and periodically we throw it to our data lake, where we do analyze the data. In our data lake, we have all this data, static, all this historic data that we analyze. In a streaming approach, we work on the data piece by piece. It will be like building a pipeline in our river. Another example, look at that aggregation operation. We have our raw data coming in here. Under the traditional batch approach, we first load that into a database, then access that data and perform the aggregation operation. In a streaming operation, we can do the aggregation piece by piece as the data is generated. So, in general terms, with batch, we have access to all the historic data, which can be an advantage for machine learning model training or some operations. But we are also spending resources in storage, in loading. In streaming, we are much quicker, we react to the data faster, and we spend less resources. So we are focusing on streaming at Quix. Thomas, since you are a founder, can you tell us how it started?
Thank you, Javi. So why are we talking about streaming here? Well, me and my three co-founders were working in racing in McLaren, and we were connecting F1 cars to the factory using a cloud to allow engineers in a factory to build real-time decision insights. And because the amount of data was really high, there's like 30 million values per minute per car, we basically find out that none of the technologies that use database could work. And this is how what led us to use streaming. So what is our approach to solve data problems where you work with the streaming data? And what I'm going to show you today with Javi. Well, it's first of all using microservice approach, which is something that software engineering really using for some time, but data teams really not. And use Kafka and Kubernetes to rely on those technologies to build a scalable and resilient systems. And then Python, because Python is language of data science and machine learning and AI. So it's all about Python today. So just quickly, I want to give you like a 30 seconds intro to a concept called pub and sub. It's very important. It's a service, microservice, that's subscribing for a topic in Kafka, so reading data into memory, and then do any sort of transformation, which could be cleaning, normalization, up to calling ML model, for example, and then sending the output to another topic. This is all what we do today, and this is the main concept. Now, just quickly, this concept allows you to scale, relying on Kafka and Kubernetes scalability. So you use partitions and Kubernetes replica system to scale your processing and transformation. And it's also very fault tolerant. So if one of the instances or hardware failures cause downtime of one of the services, the others will take the load. So traditionally, when you have system which relies on batch and databases, the project we will build today will just send data into some sort of database, and then it will use Spark or another batch framework to load the data, do some sort of transformation, and probably save it to another database, where then you load it to either your application or dashboard. Now, we do it a bit differently today. So, I have here my phone, where I'm running a very simple app, which sending various telemetry data, like a GPS location, G-force sensor data, and Javi's heart rate, which is connected through a Bluetooth, and it's now sending it to our platform. So if I go here, make this a full screen, cool, and here we have mobile app gateway, and you can see that we're already getting data from the phone. I can go here to explore the output, and I have here my phone, Samsung S20, and first I can, for example, show the G-force data. So when I shake, it's changing. When I put it on a desk, it's stabilized. Or there's a heart rate. So Javi's heart rate right now is 80. Well, it's quite fit. So cool. So this is a live pipeline working. But this is just to prove that
I feel observed, so it's going up.
So it's working. We have a live pipeline, but usually if you want to build something, you need to look at the data from bigger picture, assess the data quality, and look at all different data sources. So for that, if I go back to topics, where we have this phone data topic, I can just enable persistence here, and that will give me access. It will basically sync this data into the databases, and then give me access to historic data. So here I have the actual session, but I can look at the, for example, this one, and here the same parameters. There we are. Now, just explore what's happening there, look at it from the table view, or bring it to Jupyter Notebook to do the analysis there and possibly train models from there as well. Now, let's say I did the analysis, and now I just know what I want to build. Now that is quite simple. You just here use this pipeline view to build a memory pipeline. So I will just show you the basically empty template and how we then would build a pipeline that would calculate the calories that he's burning real time. So here, this is the pub and sub template I was trying to explain in the slides. It is a microservice that just read data from one topic, give you a Panda data frame to work with, and then you just save a different data frame that you modified to output pipeline, and that's it. So if I edit this code, leave this name, and just say I want to input a phone data, and I want to output some transform data, it gives me a Git project that I can develop locally or in this web IDE, which gives you autocomplete and everything. And it's just going to work out of box because it's pre-configured to your infrastructure. Now, as you can see here, it's installing all the dependencies for this project in the Kubernetes. And because it's done, I'm just going to run it. And this will, without any coding, get the data from the phone right now. And now it's on me to work with the columns in the frames and do something. So this is a moment when we will reconnect the laptops and how we will actually build in this pipeline that I showed you before, in this pipeline, a calorie burn in real time.
Nice. So let's recap on what Thomas has just done. He has created this app that is sending data to a Kafka topic that we've called phone data. That topic is being persisted in a database, and he's just tried a very simple transformation. I'm gonna try to go a bit further and, as Thomas said, calculate the calories that I'm burning. By no means I'm expert in calorie burning, but apparently there are two ways we spend energy. One is just by keeping alive. There are all sorts of processes that go in our body, respiration, thermoregulation, all that needs a huge amount of energy. And then we also spend energy moving. I'm gonna be using this formula over here from Knox et al. That takes both into account. And as you see there, it requires some data that I know about myself and the average heart rate over a period of time. In this case, this formula will give you the calories over a minute. So the first thing that I'm gonna do is I'm gonna interpolate the timestamps over the data points that I'm receiving. So it's not gonna be a minute. So I'm going to come over here and I'm going to add a new transformation, just as Thomas did. This that you see over here is an open source library that many people contribute to basically make streaming developing easier. So I'm sure there will be there some sort of interpolation done for me, as you see there. And that allows me to bring no-code samples if I want to. So I'm going to set up and deploy. This will be interpolation. I have the docs here telling me what this does. Input topic, output topic is going to be phone data heart. And the parameter that I need is heart. Hold on. Do you remember how it was? Okay, just like that. And I hit deploy, and this is building the microservice for me. Whilst that's happening, it will be very fast, but I'm gonna recap on what I'm doing and why it's different. If we were working on batch, we will have a set of historic data. You see there a set of timestamps with a set of values for the heart rate. So I could calculate the time delta. It will be as simple as doing a window operation. T2 minus T1 will give me the time delta between those two. And I could calculate similarly the average heart rate. But with streaming, we only have the last piece of information. So what that piece of code that we selected is doing for us is keeping in memory just the amount of information that we need for our operation. So at T2, we will keep in memory information from T1. At T3, we will also have T2, but not T1 anymore, and so on. That's what the interpolation element that I'm using is doing for us. And there you see, it's already working there. When something is working, we can check the console. We can check the amount of data coming in and out, or we could check the actual raw data. So there, I can have a look at how a message looks like in the input, and I can select the output as well to see how that transformation is converting my data. You see now that not only I have the heart rate, but also the delta time and interpolated heart rate that I needed. With these values, I'm now able to calculate the calories. So I'm going to do just that. So I'm going to add a new transformation. This brings me to the library again. Only this time, I'm going to start with an empty template, a hello world example. So I'm going to edit the code. This will be listening to the phone data heart that I was outputting to before, and it's going to be outputting to a new one, to heart calories. I'll save as a project.
So each item that you see here is basically one independent microservice that I just connected together using Kafka.
Now, this is a 20-minute presentation, so I have the code ready here, so I can copy and paste. But that thing that you see there is just a function that reproduces the formula that we were seeing in the slides, the Knox et al. That we talked about. This function requires a time delta, and it will calculate the calories over that time, giving an average heart rate and these other parameters. And now here is where I will react to the data coming in, doing whatever transformation I need. Again, I have that code copied over here for us to save some time. So I'm going to copy, and pasting here. And let's see what this is doing. So in this function at line 27, I'm reacting to new data coming in. Then I'm calculating the calories burned over the last time delta with the function that I had just defined here, and with the parameters that I had created, the interpolated heart rate and the delta time in seconds. Weight and age, I'm going to assume they don't vary, so I keep them as that. I'm printing to the console, and then I'm adding a new column to my data frame. The incoming data, we have it in a data frame format, by the way, which makes transformations much easier. And then I'm just outputting that data frame to the output topic. In a single line, this will be much harder if I had to do it with Kafka myself. So I'm ready. I'm going to commit this code to the repo, and I'm going to hit run. And if everything works fine, that, everyone, is the calories that I'm burning over time.
So basically, what we try to show you here is that transition of building a data science in Jupyter notebooks to build data-driven products and have people working directly on products. So Javier basically here directly adding features to potential application that we obviously don't have here, but you can imagine it would be some fitness app or anything. He directly is sending output of his code to a topic that then application engineer can just subscribe to in a mobile application or web browser or anything. So
yes, think of this like Thomas is the data engineer or software engineer. He's been able to create the ingestion system, and I, as a data scientist, I've been able to deploy it in a production solution. Now, we just have 2 minutes to go. I hope you've enjoyed this quick presentation. There you see my calories being burned in real time. If I move a bit, I guess, I will get my heart rate up and the calories will start moving up. But I hope you've enjoyed it. If you have, feel free to scan that code and sign up into Quix. We have a free developer account. But if you are interested, do it now, because our colleagues have prepared a special offer where we have the double amount of free credits that we have usually. So we're going to believe that we're going to be downstairs in the first floor in our stand. So please come talk to us, sign up, and thank you for your attention.